Hey everybody, and welcome back to the channel. In this video we're going to be taking a look at this iconic card from nVidia, the Riva128. This is the PCI version of the card from Diamond Multimedia. Now there's also an AGP version also from Diamond Multimedia, and this was actually one of the first AGP cards alongside the Intel 740. So I have both versions here, which will make it very interesting to compare them. Now the Riva128 is an iconic card because this is one of the first times where crisp 2D performance was promised together with 3D effects like 3D performance on a single card. Now, like I said, this is a card from Diamond Multimedia, released in 1997. This is the Viper V330 PCI card with 4 megabytes of video RAM. And we're going to try it out on my compact Desk Pro Pentium 2 machine here that I already used for the ATI Rage Pro Turbo. And I'm also going to be using this Diamond Viper V330 AGP card. So that will make for a fun and hopefully interesting comparison. Now, I already had a Diamond Viper V330, but unfortunately it was broken. Now, I did release a video where I attempted to fix this card, but unfortunately I failed miserably at that because the damage, I don't know if this was the only damage to the card, but I didn't manage to fix it. Now, one of my subscribers, Christoph from Germany, took note of that video and he actually sent me this big box full of goodies. It contained lots of stuff and it also contained a computer. And inside that computer, it contained a video card. And wouldn't you know, it was also a Diamond Viper V330 PCI card. So yeah, thanks again, Christoph, for providing me with this package. I'll link the original video here in this video, but yeah, really appreciate it. And now finally we can get to see how this card performs. Yeah, it's a really clean card. I really like the Diamond Multimedia logo and the Riva128 chip. So I also like the fact that it's PCI. I mean, there is also an AGP version, which will probably be somewhat faster, but the fact that it is also comes in a PCI variant is very interesting, especially if you have a computer which only has PCI slots. Now, my computer both has PCI and eAGP, so I can compare both of them. So let's plug in the PCI version and get things started. Installing the drivers is easy enough as there are reference drivers from nVidia which are available. By default, the video card is detected as a standard PCI graphics adapter, so we only need to update the driver, point the device manager here to the location where our nVidia reference drivers are. And this is version 3.37 for Windows 98. There is a specific PCI version of the drivers and AGP version, so we're going to be installing the PCI version here. It's basically next finish. It builds a driver information database, but after a reboot, we should have a nice looking desktop with 16-bit colors. And here we have it. Now, unfortunately, I had lots of issues with my video capturing device on this particular card. So I'm going to attempt and showcase the drivers here, but it's going to be a bit stuttery. So there's this Riva128 tab that we have in the driver sections, allowing you to configure all kinds of stuff. So we have some settings here related to direct 3D performance and compatibility, stuff like fog table emulation, square textures, advanced settings like the per pixel MIP mapping that you can enable for quality or either performance. We have some various addressing mode. You know, all of these settings probably deserve a video on its own and kind of seeing or trying out what the impact on individual games are. We can, for example, here enable or disable anti-aliasing, which will probably give a huge effect on some games. But yeah, stuff like brightness, contrast, gamma sections. We have some OpenGL texture quality And finally, in the About section, we have some information on the driver version. Now, another interesting piece of software is Everest Home Edition, which besides some basic information on the computer, can also give you some more detailed information on the graphics card. So depending on the graphics card and the driver, you will get less or more information. So here it's pretty extensive. For example, the memory bus here, we can see that it's 128-bit with a clock of 100 megahertz. Giving us a throughput of 1.6 gigabyte per second, which is a lot more than the ATI Rage Pro Turbo card we saw earlier, which only had a 64-bit bus and a 75 megahertz clock. Now, time for some benchmarking. Now, I wasn't able to capture this on my capturing device, probably due to some refresh rate issues, so I had to just video the actual monitor, so my apologies for that. But as you can see here, the race is running okay-ish, but it does look different than compared to the ATI card. So here on these images that you can export from 3D Mark 99, you can actually see that the sky is really dark, and when you look at the reference picture here, you can see that the sky is a lot more brighter. And that's something that I really noticed while doing these types of benchmarks. Now, one of the things that surprised me the most was the performance of this first-person benchmark in 3D Mark 99. I mean, the performance was just way off. It was barely able to reach 3 frames per second, and performance was like really awful. And that accounts to the very low score that this card got in 3D Mark 99. As you can see here, one of the runs barely got 500 3D marks. So yeah, a really poor score. Now, I did ran a number of benchmarks here using this card, all on 800 by 600 with the same settings. The only difference here was the refresh rate, because I was kind of playing around with my capturing device. But you can see here that the scores basically range from 471 all the way up to 577. So there is a big difference between the low and the high score here. But everything is due to the fact that this first person game is really slow, and half a frame per second basically makes a huge difference in the final score. So as we walked through these scores, CPU mark is almost the same, the rasterizer score is the same, the race game is the same. Here on the first person, you can actually see that the fastest run was 3.6 frames per second, whereas the slowest one was 2.8 frames per second, and that makes up for a total of 100 3D Mark score difference. All of the rest was basically spot on the same, so it's just that one benchmark that just makes a huge difference. So let's compare the ATI Rage Pro with the Riva128, and let's just go to the overall result. So here we have the Riva with 577 3D marks, whereas the ATI was able to score 1200 3D marks, which is a substantial difference. But now as we scroll around the different results, synthetic CPU speed is obviously the same, but let's look at the rasterizer score, where the Riva scores a lot better. Also in the race game, we get more FPS, but here in this first person shooter, there is a really big difference between the two, and that makes up for the poor scoring of the Riva128. So that just goes to show that these kind of synthetic benchmarks like 3D Mark 99, I mean, they don't really tell the full story. In this case, I can guarantee you that the Riva128 is a lot faster in a lot of games, as we will see now, starting with Quake. For example, here when we run the Quake time demo, which is running really fluently here with the Riva128 and also looks really good, you will see that it actually gets a really nice score for a system like this. So let's just run this till the end. And as you can see, we get almost 50 frames per second, which is, a substantial improvement over the ATI Rage Pro. Let's go to Quake 2, which is a little bit more of a demanding game. So we're gonna just run the demo 1. This is version 3.2 of Quake 2. And again, it looks really nice. Performance is also really good. I actually didn't run this demo on the ATI in the last video, but I did take some notes here on the actual score of the ATI Rage Pro Turbo. And again, it was a lot slower than this Riva128, where the Riva128 managed to score 32 frames per second, and the ATI Rage Pro only managed to score 20 frames per second. Okay, now let's raise the stakes and put it up to 800 by 600 and see how she goes. Again, gameplay is pretty fluent, so I am expecting a pretty decent score for this run. And indeed, we finish off by hitting almost 24 FPS. Now, another great game is Quake 3 Arena. It's always a nice game to play and to benchmark. I like these games that have built-in benchmark because they give this kind of objective view on the overall performance. So let's load up the time demo. We'll display the frames per second. So Quake is able to display the frame rate. I also have Fraps running, so you'll see both the Quake engine drawing up the frames per second as well as Fraps. But yeah, definitely it is playable. It's not super. I mean, this game really does benefit from a more beefier graphics card as well as a CPU. So, I mean, if you're playing this in kind of an esports setting where you really want to play this, you know, semi-competitively, this will definitely not be enough. But for the casual game, it's definitely playable. So we're getting about 20 frames per second here, and this is actually not bad for, you know, an early 1997 card like the Riva128. So let's take a look at the numbers here for the various Quake versions. And one thing is definitely obvious, and that is that the Riva128 vastly outperforms the ATI 3D Rage Pro, usually by a factor of 2 or more, except perhaps for Quake 3, where, you know, the Riva is still a lot faster, but the difference is a little bit smaller. I don't know if this is related to drivers or OpenGL implementation, but I was using the latest drivers of the ATI 3D Rage Pro. And another thing that I noticed is that the difference between the Riva128 PCI and AGP also isn't all that great. So next up we have Midtown Madness, another classic that I often use in these videos to, you know, get a feel of the performance of a card. So let's go into the options. Let's see. So everything is set to medium. It has detected our Riva128. So for this system, it does recommend 640 by 480. And you can see that the far clip distance and the lighting quality is set to almost 0. And as we start the race, you immediately see that it doesn't need to do a lot of calculations to render the horizon or objects in the distance, because it's basically just sky. Normally there would be lots of buildings there, so right now it's doing this kind of just-in-time rendering, and that really benefits the overall frame rate of a game like this on a lower end system. But the graphics card is definitely able to keep up, so we're getting somewhere between 20 and 30 FPS, which is okay. I think this will max out at around 35 FPS or something like that. But you can see here, even on, you know, busier scenes, we're still able to get, you know, somewhere between 25 and 30 FPS. Now let's raise the stakes again. So we go into graphic options, and let's just put the far clip distance all the way up, as well as the lighting quality, and see what the difference is. So here you can see that it needs to render a lot more stuff in the background over there. But still, we're getting a decent frame rate. So we start off at around 25 FPS. It will drop a bit when the scenes get a little bit more busy. So here you saw a drop of around, you know, 15 frames per second. But overall, the game is definitely still playable. And this is something that, you know, the ATI Rage Turbo Pro was definitely struggling a bit, especially when you hit this section here of the game. It wasn't fluent at all, and here it basically it renders everything just fine. However, as soon as you bump up the texture resolution, let's put this too high and bump up the object detail, you will see that the game becomes virtually unplayable. So let's start a race. We'll use the same car just for reference. And again, you can immediately see that it starts to stutter. The texture qualities have definitely improved, but you know, we're not even hitting well, 20 FPS occasionally, but overall, I mean, the average frame rate has dropped a lot. And as you can see here, for example, it basically almost grinds to a halt. And yeah, you're basically maxing out both the system and the graphics card at this point. So we're not going to even attempt to run this game on 800 by 600. So the next game I wanted to try with the Riva was Need for Speed 3, and I've always enjoyed this game and I like the aesthetics of it, especially the menu system. Now on the ATI 3D Rage Pro, it didn't really look like it did on the Riva128 because the menu actually looked like this. So it definitely had issues rendering this menu screen, probably also OpenGL related or driver related, but I wasn't able to fix this, not even with the latest ATI drivers. But luckily with the Riva card, this menu portion rendered fine. So let's go into the video options, go into graphics, and we'll select 640 by 480, put everything in high, put on the chrome, put on the shades, and let's see how this game performs. And we're starting off at about 38 FPS, which is definitely good. Game looks really nice. And gameplay is really fluent as to be expected. It's a little bit faster than the ATI Rage Pro Turbo. Here we can see the cockpit view, something that you cannot see, by the way, if you're using something like a Voodoo Rush or a Voodoo Banshee, I believe. So yeah, game looks really, really nice. Just look at the car reflection. It's really fluent, 30 FPS, and things are looking good. And let's see how she behaves when we up the screen size to 800 by 600. Again, 16-bit colors. And we start off with a slightly lower frame rate, but still definitely playable. It's plus 20 FPS, despite the higher resolution. Although it does dip a little bit as soon as you have like a lot of smoke. But yeah, still playable to some extent, although I do prefer the lower resolution and the higher frame rate. But yeah, this is something that definitely the ATI Rage Pro wasn't able to manage. Final Reality also ran fine on the Riva128. It kind of got around the same score as the ATI Rage Pro Turbo AGP card. There wasn't a whole lot of difference. I mean, the robot scene and the city scene basically performed more or less the same. So yeah, not a huge difference in that respect. But unfortunately, not everything is fine in Riva128 land. Just look at this Formula One racing simulation. Lots of distorted artifacts. Just look at the track here, which kind of flickers away. And also when playing the game, the frame rate is really abysmal. I mean, we're not getting close to the speeds that we were getting with the ATI Rage Pro. Probably this game needs some kind of patch. But yeah, definitely worth noting that, you know, some of these early games will definitely give you some compatibility issues with this card. And we see a similar thing with this Millennium Racer game. I mean, there are some distorted graphics here and there, and also the frame rate isn't really what it should be. So there are definitely some games that have compatibility issues with this Riva128 card. And you have to see things in perspective, because predominantly a lot of the games were like written for 3DFX Voodoo based cards using the Glide API. Direct 3D was becoming more of a standard, but definitely a lot of games weren't patched yet to a sufficient level that all of these would work just as well as they did on a 3DFX Voodoo card. So yeah, definitely some mixed results there. And I was wondering if this was somehow related to the PCI bus, because this is obviously a PCI card and performance should be held back a little bit by that, because obviously we also have the AGP counterpart of this card, which should in theory perform a lot faster. I just wanted to see to what extent there was a big performance difference between the two cards. So time to swap the PCI version out and put in our AGP version of the Diamond Viper V330. And I have to say there wasn't a huge difference between the PCI and the AGP card. Obviously, in benchmarks like 3D Mark 99, you're bound to see a difference because, some of the tests really test the overall throughput of the card, and for example in terms of textures, but for a lot of these benchmarks it's basically the same. I mean, the race game obviously runs a bit faster on the AGP card, but it's not really a huge difference. So yeah, overall I think really impressed with the PCI package of this card, and it basically holds its own when it compares to the AGP card. And again, if we look at the numbers, the Riva128, both PCI and AGP, outperforms the ATI 3D Rage Pro. Only in the Formula 1 racing game, we noticed that the ATI 3D Rage Pro was a lot faster. I guess this has something to do with compatibility issues between the game and the actual card. Also in Millennium Racer, I noticed that the Riva128 wasn't performing all that well, but in every other game, it vastly outperformed the ATI 3D Rage. So in that respect, it's a much better card for overall gaming than the ATI 3D Rage Pro. And that about wraps it up, our little trip down memory lane with the Riva128, an iconic card from nVidia that really kind of democratized the whole 2D, 3D acceleration, all in one package, available both in PCI and AGP. I think this was a card that a lot of us had back in the day as kind of an alternative or replacement for the original Voodoo card. Thanks again to Christoph for the kind donation of this card. I really enjoyed my time with it. I hope you've enjoyed this video. If you did, please consider giving it a like, dropping a comment, or subscribing to the channel if you like this type of content. And I hope to see everybody in the next one. Bye bye, take care.